All right. So, let's start off with something that's going to look very familiar to you. As a matter of fact, you have to learn this all the way back probably in 5th or 6th grade. Okay? And the concept of adding fraction with like denominators. You should like that because we don't have to find the LCD, do we? Okay? So, for instance, if I give you a problem like this, let's just turn this off, for example. Ooh. 2/5 plus 7/5, for instance. How would you solve that? 9. Okay, so now we all know it's 9/5. Who in this class still think that, hey, if we're going to be adding, we should do it like multiplication. We add the top and we add the bottom as well. So instead of 9/5, our answer should be instead 9/10. Who thinks that that's the case? Okay. If you need some convincing, I can certainly show you that you cannot add the bottom. Well, of course, if you have like denominators, they should stay the same. For this good reason. For example, okay, pretend that I have 2 small pizza right here, and I'm going to go and cut this in half. Agree? Yes. Exactly in half. So I'm going to consume this half, and I'm going to consume this half. So this is exactly 1/2, and this is exactly 1/2. How much of the pizza did I just eat? Half. The whole thing, because a half over here and a half over here, they're the same size, so technically a half and a half together, you should get the whole. And the whole means, so technically speaking, 1/2 plus 1/2 should be 1 whole, right? Yes. Now if you try to say, okay, well if I'm just going to do it with my technique of 1/2 plus 1/2, and I add the top and I add the bottom as well, guess what the answer is? 2/4 reduced to 1/2, so you're basically telling me that 1/2 plus 1/2 is 1/2. See it? Which does not make any sense, right? You see what I'm saying? That's a good reason for you to at least convince you that, hey, if I have the same denominator, I would never add the bottom at all, ever. Okay? We just deal with the top only. Is that clear enough? Okay. Now, here's another one. I just want to test to see if you recognize this. Ready, guys? Yes. Tell me if they are the same or not the same. I have n minus 5. So that's one side. So tell me if the left and right, they're the same or not. On the right-hand side, I have
Same.
I have -5 plus n. Tell me, are they the same or are they different?
Same.
Really?
No.
Oh, see that? Just because I put that question out there, I put that question out there, say, really? And you changed your answer right away. Why is that? See, you got to stand your ground, man. Man up and say, you know what? Just do it. Because you say, no, I'm thinking of that. If you are so certain that these two look exactly the same no matter how it's written, then you just say, yes, it is, Mr. Wright. They're the same. Even if I ask, are you sure about that? See it? Okay, so, well, and the answer is yes, they're the same. Why? Because realize that I have a positive n here as a term, and I have a -5 here as a term. If I have to compare term by term, don't I still have a -5 term and a positive n term? And you know that addition is commutative, and therefore I can certainly write this as n minus 5, and it looks exactly the same. We're cool with that?
Yep.
So learn to recognize whether something or not is the same, even if it's written out of order. What we really care about is, do we have the exact sign and the exact number, right? Now here's the next one. Think carefully before you tell me if they're the same or not. Here we go. That's 1. That's 2. Now,
No.
think carefully.
No.
Are they
No.
the same?
No.
Are you sure about that, Duke?
Yes.
Yes. Sure.
Yes.
Are you willing to bet your life? Okay, so, yeah, they're not the same. Why? Yes.
Because on that side it's positive.
Very good. Do you realize that if I take out all the signs, technically they have the same exact number and variable, right? But if I put back the sign here, you see that this is a positive n on this side, and this is a negative n on this side. This is a positive 7 here, and it's a negative 7. So they're almost the same, except for what? Each term is what to each other? They're opposite of each other. So today, guys, I'm going to teach you a little technique here to not say change the actual term, but to rewrite it so that it almost looks identical. And it is for a good reason, because remember, our whole lesson today is about common denominator, right? And when we say we have common denominator, it must look exactly the same. So right here, if I'm asking you, do they look the same? You're saying no. But do we have a way to perhaps rewrite it to make them almost the same? And let me show you that way. You can pick either one you want. I don't really care where you start. But usually, the way that we want to write it is where the variable comes first, then the number, right? Because this is the power of 1 and this is the power of 0, so we want to put it in order from greatest to the least. So therefore, I'm going to start working with this term right here because the variable and the numbers are out of order. And the way that we rewrite is a little trick of extracting the negative out of each term. Think about this. So that means if we extract a negative out of this, watch what happens if I do this, okay? If I take out a negative, then the entire thing can be written like this. Is that true?
Why is the negative over there?
Watch what happens. No. Watch. Is that true that this bottom here is the same thing as above?
Yes.
If you distribute the negative 1.
Because you
Yeah.
multiply
Yeah.
together,
See it, right?
Yeah.
So that is negative 1 times negative 7, which is positive 7. A negative 1 times a positive n is a negative n. But watch what happens next. We also realize that we can actually rewrite or switch the term. So if I switch the term, would it look like this?
Uh-oh.
Is that true? Is that still the same thing? I still have a negative n when I distribute. I still have a positive 7 when I distribute. So technically speaking, I did not change the value of anything here. I just rewrite it, but in the process of rewriting, I want you to check again. Look at this.
Uh-oh.
They are now almost identical, except for this negative 1. But that's what we want. The best that we can do to make them look almost exactly the same. Okay? So this process right here, basically, we want to extract at the negative. So it's like the additive inverse process. Okay? So we see that little trick right there? I want you to use this little trick when we get to the right situation. So I'll show you that case in a minute. So once we have this settled, it's all good to go. I want you to show our first problem here. Here is our first problem. This is our fourth problem already. And here's our problem for today.
Oh.
Don't,
No, but that's not a song.
Think about this. I have a trapezoid, and I want you to find the perimeter of this trapezoid. Okay? How do we find the
Yeah,
perimeter of the trapezoid?
Oh,
Yes.
Oh, we have to solve each one of them and then add them together.
We don't have to solve each one. I'm just asking to simplify, really.
Oh.
Just give you the basic definition
No,
of
never seen you raise your hand.
the perimeter of a trapezoid. How do we find the perimeter of a trapezoid? Yes, Jeff. Yes. Add up all the sides, right?
Yes.
So that's the basic definition of any perimeter for that matter. Any shape, I don't care, I just add up all the sides. Did I give you all the sides already?
Yes.
Yeah.
Okay, so if I give you all the sides, then I want you to go start adding it up. Can we?
Yes.
Yeah.
And first of all, check this. Each one here is represented as a rational expression, or in this case, fraction. And every time we deal with fraction, we have to think about, wait, do we have the same denominator?
Yes,
Do we have same denominator?
Yes.
We do. So, because if you verify carefully, here's h plus 1, h plus 1, h plus 1, h plus 1. They all look identical, so I do not need to find LCD. That means we just have to worry about the numerator, right? The top. Look at the top. What do we do with the top? Yes, we add them all up, but don't forget, because we have a mix of variable numbers, we are trying to combine what? Like terms. Do we know how to combine like terms?
Yes.
So let's tell me. Let's look at all the h's. How many h's do we have if we combine them all?
Wait, 8.
4?
Wait, if we combine?
If we're going to combine them all, right?
25.
How many h's do you have?
25.
25. Look at this. How? Look.
Yeah.
Oh, yeah. How, right? Look. 5 plus 5h, that's 10h. 7h plus 8h, that's 15h. 15 plus 10, 25. You gotta choose your number, right? So we have 25 h's. So at least on the top now, we know we have 25 h's. 25h. And what about the number? Do we agree on that? You have negative 14 plus 1 plus 1. That's negative 12. Is that correct? And what is our denominator?
H plus 1.
That's it. Now,
Well, that's
easy.
easy. Watch.
here's the question though. Can we still do something to the top?
Yeah.
Yes or no?
Yeah.
See, when it asks you that question, you like, is there a GCF that we can take out?
No.
No. Can we actually take 25H and minus 12 from it?
No.
Why? They're not like terms. Okay? This is a variable term. This is a number term. When I say it out loud, you should know that, hey, that's not, they're not the same. This is a variable term. This is a number term. They don't sound the same to me. Can't do anything to it, so I leave them the same. So notice that the chart that I gave you before is still at play, right? Don't forget that every time you have 2 or more terms, you always ask this question. Is it in order? Is there a GCF? And it was 2-term dots and so on and so on. Okay? But are there any questions on how to do this problem so far? But you see the basic technique of if I have the same denominator, I just have to combine the top. Notice I did not use the word adding or subtracting. I just used a general term of combining because when I say combine, it will take care of itself. If I have a -14 combined with -7, you know that you're going to add. If I have a -5 combined with 8, you know you're going to be subtracting. You see it? Because of opposite sign. So with that in mind, I want you to see this problem and try to work this out on your own. Here it is. Go. I have 8 over 12
Oh, I got this.
plus 2a over 12.
3/8.
Okay? Now I want you to go ahead and do the best you can and simplify as much as possible. Do that.
Simplify. No. You can do.
Do we have the 12 and 12?
Yes.
Oh, see that? Do we have the denominators, guys? We don't. Okay, so at least, for most of you, you should be able to set that up. I know the denominator remains the same. I look at the top now, the numerators, and say, well, I have a plus 2a. Some students still think that a plus 2a is 2a squared. Is that true?
No.
I mean, so I gave them this another example again. How many a do you see here, guys? 1a. How many a do you see here? 2a. 2a and 1a becomes 3a. Okay? It's that simple. So when I say combine like terms, that's what you're doing. Counting the numbers of variable you see. 1a, 2a, 3a. Okay, done. Fine, you have 3 on top. Now, for those of you who think that this is done completely, you're not quite there yet. Because you realize that 3 and 12, you can actually do something to that, to those. What, divide what? By 3. So if you divide both by 3, you end up with a over 4. And now this is what we call the simplified answer.
I thought you couldn't do it because like the variables.
No. Don't forget. Hey. Listen. Isaiah, don't forget that 3 times a, they're linked up by multiplication. 12 is 4 times 3, linked up by multiplication. Didn't I just say before that if they're all linked up by multiplication, we can actually cancel out? We can do that way too. Is that still a over 4? Look at that. Okay? Is that clear enough?
Yes.
Alright. Here is this problem you want to try. Go. Do carefully. Work carefully, please. I want you to try and simplify as much as you can. So, think about this. I still have students trying to add unlike terms together. Not possible, right? Don't do that. Don't force yourself to do something that's not normal. So for instance, first of all, we know that 3n and 2, they are the same denominator already, so I can just go ahead and put that underneath it. And then on the top though, yes, Isaiah?
We put 12n plus 8.
Yeah, just leave it like that.
But that's the same thing.
Whoa, no. Wait, we're not done yet, are we? Look, this is 12n plus 8 over 3n plus 2. Of course, I'm trying to warn you one last time. Hopefully it will stick. 12n and 8, they're not the same. They're not like terms because 8 here does not end in n. If this is like 8n and 12n, I have a total of 20n. Makes perfect sense, right? Right? I have 12 n letters and I have 8 n letters. It's a total of 20 n letters. But this is 12 n and this is just a regular number 8. I cannot combine them. But even though I cannot combine them, I realize that 12n plus 8 here, 2 terms, I take out the GCF. Is there a GCF for 12 and 8? 4. If you take out a 4, what do you have left inside? And the bottom is 3n plus 2.
So it's 1.
The answer is 4.
Oh.
You see how simple that is? And I also want to remind you about this. That every time you're done factoring, maybe you take out everything you can and there's nothing else you can do, get into the habit of putting extra parentheses around it so that it reminds you that, hey, I'm done with this. I don't touch this anymore. I do not have to take out the GCF. There's nothing to break down, no factors from here because it's already completely factored. So put in extra parentheses just to remind you about it. Okay? Oh, look at that. That's how you solve a problem. Or not solve it, simplify the problem. Okay? Questions? Alright, here, do this next one. Okay, now, this problem has a little twist to it. And I really want to bring this up because, first of all, check carefully. Do we have the same denominator? Look carefully.
No, but we can make it the same.
How do we make it the same?
Okay, so then you put the -1.
Okay, so remember. Good. Look. Basically, this looks fine, right? The variable in front, numbers, good. This here is the term that we want to rewrite. How do I rewrite that term?
Can I go up and write it?
No, you can tell me.
Okay.
Yes, go ahead. Well, let me rewrite the whole problem first. Here's a 2n minus 5 on this side. Notice I put in the parentheses to indicate that I'm done factoring. It's done for that side. What about over here?
Okay, you put the -1.
So you extract, you basically performing what we call the additive inverse, or extracting the -1 outside. What do you have left here inside?
-5 plus 2n.
Can we just rewrite it already to make it look exactly the same? Is that correct?
Oh.
Is that the same thing? -5 and 2n? I know you said -5 plus 2n, but can we just go ahead and use commutative property to change it back
Yeah.
to 2n minus 5? But look, in the process, yes, I did rewrite the whole thing, but if I distribute back to -1, I still get the exact same term. See it? But in the process, look, they look almost identical. So the only thing left to do is I need to get rid of this -1 myself. How do I get rid of this -1? Very good. Or what you could have done is this. What's 5 divided by -1? So that now becomes this, isn't it? -5 over 2n minus 5. Do we agree?
Yeah.
See it? So I can just do a quick division right there, and the -1 disappears. So 5 divided by -1 becomes -5. So this problem now, before it was an addition problem, turns back into a subtraction problem because I divided by negative. It turns back to a negative. And look, do I have the same denominator?
Yes.
I do. So what do I do? Have 2n minus 5 on the bottom, of course. And the top?
2n
Oh.
minus.
Ah. Oh, is that identical?
1.
1. That's it. That's all there is to it. Okay. Do you see this useful trick that you will be using a lot? Additive inverse. Making sure that you use this effectively, guys. So here's the problem I want you to try it on your own. Go. I'm going to go ahead and use the first approach. I'm going to say this. Oh, I do not like the look of this. I want to turn this to look like the right-hand side. See, I can choose either one. I don't really care. So if I choose this to rewrite, that means I'm going to extract out a -1, and then all of a sudden, it will be written like this. Is that correct? Tell me that it's right. Is that true? Right. And then the next thing you do is, okay, how do I take... Huh? Whatever you want.
We can switch the other one.
Yes, you can. But why did I decide to switch to this one? Because I want to follow the convention of the variable goes first and the number goes last. That's why.
Oh.
You see it? If you write it the other way, it's kind of reversed. Not that it's wrong to pick the other one, but it looks awkward to me. That's why. Okay. All right. So, the only problem that you have is this, and I want to address this. The previous problem, you only have one term on top, right? And this is a -1 on the bottom, so you can easily divide it and take the opposite number. Done. But notice that this time around, you don't have just one term on top. You have 2. I don't care how many terms you have on top. each term on top will take on that negative 1 by itself. Do not just think that, oh, it only applies to x or only applies to the y. It applies to both terms. And because of that, watch what happens. If I'm going to be applying a negative 1 to each term on the top, what is x divided by negative 1 going to get you? Negative x. And what is negative y over negative 1 is going to get you?
Why?
Positive y. So now, the negative 1 is gone. You see how I take care of the negative 1?
Yes.
Okay, and of course the other one is the same. Oops, it's x plus 1. Okay, look, do you have everything looks exactly the same now? I took care of my negative 1. You see it? By dividing to each term on the top. And I'm done with that. Now, all I have to do is combine like terms. Look, here's the x and here's the x. What do I do with negative x and x? 0. Cancel. What do I do with y and y? 2y. And that's my answer for that. Okay? Now, if you choose to go with the other route, I want to show you. So please, write this answer first. Go ahead and write 2y over y minus 2. I'll show you the other approach right now. Ready? Okay, so the previous one is 2y minus over y minus 2, right? So that's the first answer. Agree? If you decide to go with the other approach and say, I'm going to go and rewrite this one right here instead of the other side. Nothing's wrong. Nothing's wrong with that. Watch what happens when I rewrite it. You have x minus y over 2 minus y over here. And you realize that if I'm going to rewrite this, I will take out the negative 1, and I will end up with this. 2 minus y. And you have x plus y on top. Agree? And then, of course, next step is to take care of this negative 1 by taking each term on top and divide it into a negative 1 on the bottom. So x divided by negative 1 will give it a negative x, and y divided by negative 1 will give it a negative y, right? So when I rewrite the whole thing, it will look like this. Negative x, negative y, right?
Plus? Isn't it a minus?
Huh?
Did you put a minus there?
Well, this is combining, right? But you can certainly change it to minus if you want. It's fine.
Oh, okay.
Over 2 minus y, correct? Okay. Now is the time to combine like terms. I have x and I have negative x. What is that? Cancel. I have a negative y and a negative y. That's a negative 2y. So now you look at what I have here in green and what I had in the pink. You say, wait, they don't look exactly the same as them. What's going on? Are they different? No, they're not. Watch this. If I actually test, okay, do a little test on this, and say, let's call y to be, pick a number. 1. If I pick 1 and plug it in, that means it's 2 times 1 over y minus 2, right? This becomes 2 over negative 1, which is negative 2. Watch what happens. If I take a 1 and plug in the same here, so that's going to become a negative 2 times 1 over 2 minus 1, right? This is a negative 2 on top as well, over 1. Negative 2 over 1 is still negative 2. So they're technically the same thing, just written differently. So how do you fix this? You just have to take out the negative 1 here and then divide it, and you get back the same exact form. So I don't care which approach you do. It's still the same. It's written differently. Okay? It's like you having another nickname or something. That's it. But it's still you. All right. So that's what I want to talk about. Are there any questions on this? Okay. Good for you. All right.